we're going to start with our review, kind of getting ready for our quiz/test here tomorrow. And just some review type things to kind of go in with the stuff that we've been doing. Solve by taking the square root. But again, we have to get x squared alone first. Now if it is, that's awesome, because then I can just do the square root and be set. But here's our dilemma. Our dilemma here is, if I just went to the calculator, which sometimes we do, and we'd be like, okay, so I want the square root of 25, and you hit it, and you go, okay, it's x equals 5, and you go on to the next one, and then you find out later that you missed something, because there's not just one answer here. That squared means that there's going to be two answers here. So here, it's not only the 5, but it's also the negative 5 that we've got to that solution. I have to have both. So whenever I solve by the square root, I'm going to get two answers. So that's something I've got to be cautious and aware of. If x squared isn't by itself, and like I said, I'll do some different parts in here to kind of help out a little bit. I've got that minus 20 that's not in the box. That's not my x squared. So I'm going to do the opposite. And I'm going to plus 20 to the other side. So when I do that, now it looks a lot like number 1 did. I look at that and I go, oh, well, that wasn't a big deal. The only thing, again, I've got to remember is when I get my square root, that I've got to have the plus or minus or only have half the solution there. Okay? And the only other one that can kind of throw us a twist are the ones that are like 4 through 6. So I'm going to jump in and do one of those just to kind of get you kick-started. Number 4, I can't get to just the x. It's in the parentheses. So in this case, what I need to do instead is go ahead and do my square root right away. And the only reason I can do that is because the x is in the parentheses. But here's the kicker. What's the square root of 36? 6. So I'm still going to do my plus minus just like I did up here when I did the square root, except now there's one step left to go. And that's going to be to do my minus 5 and what that's going to allow me to do is to split this into two answers, because I got to find them both. I don't want to just leave it this way because I can actually get to the answers. So I do negative 5 plus 6, and I do negative 5 minus 6. And then I actually find those two values, and I have the two answers. So it won't just be that number plus minus every time, if there's parentheses. Negative 5 plus 6 is 1. If I owe somebody $5 and I borrow 6 more, now I owe them 11. So that's how 4, 5, and 6, bless you, are all going to work. Take the square root first, and then just kind of break it down from there. The quadratic formula that we've talked about some too. And yes, you will, when we get to the test tomorrow, be given the formula. So you just got to do is plug in the numbers, but we'll write it on here for now. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, my a, b, and c are just the numbers in front of x squared, x, and then at the end. But I want to do number 8 with you here because it's a little strange. But we made sure a little note over here on the side. It says set equal to 0 first to be able to find the c value. In other words, I need to get that 8 over here with everybody else. 8 wants to be part of the party going on the left side of the equation. So I've got 5x squared plus 9x. Positive 2 minus 8 is negative 6. And once it says equals 0, now I can go get the values that I need. Now I can go and say, oh, the number in front of x squared is my a, so that's 5. My number in front of x is my b, that's 9. And my number hanging out on the end by itself is my c, it's negative 6. And then I plug them in. And we talked a little bit before, as we're plugging these in, we're like, okay, so negative b plus or minus the square root of b squared, always want parentheses there, minus 4 times a times c all over 2 times a. Now, we talked before about trying to plug this all into the calculator at once is not an easy thing because there's lots of issues that can come up with parentheses and all that type of stuff. So here's my suggestion again. I'd deal with just what's underneath here. So here's how I would do it. I would do, and I wouldn't even do the square root yet, just because I want to keep life simple. So I'm just going to multiply all that stuff together. Once I do, now I can get all of this stuff going. So I'm like, okay, so I've got negative 9 plus or minus the square root of 201 over 10. So when I go to split this into my two answers, I'd just do it piece by piece here. So I'd be like, okay, negative 9 plus the square root of 201. Okay. Now here's one suggestion I'd make too. If I were to put in the divide by 10 here, here's why this is a bad idea. If we're doing order of operations, it's going to do this divide part, and then it's going to add negative 9 to it. You're like, but that's not what I want to do. I want to add these up and then divide by 10. So what I would do is I'd go ahead and just type that part in, hit enter. So the negative 9 plus the square root of 201, and then divide it by 10. You're going to get a funky answer. So like 0.52 we'll call it. We'll just go to a couple decimal places. And then I'm going to do the exact same thing, except, of course, the other part of this is to minus the square root of 201. And then divide it by 10. So take it in little pieces. It's like when you're eating food. You don't eat the whole steak at once. At least I hope not. And number 7's actually set up and ready to go for you. Just plug in A, B, and C. But it kind of lets me see how this is going to work. So again, take it in little pieces. I'm sure it'll work out fine once you do that. And then we kind of get back into our regular factoring stuff that we've been just pounding away at here. Okay, so factor each, do not solve. We'll do a couple of these. So if I look at these two terms, what do they have in common, whether it's a number or variable part? Does anything divide into 5 and 10? You're on the right track thinking a little further down the road here, okay? So 5's divisible into each of those. And again, whether it's the chart, calculator, your brain, doesn't matter which. Anything with the variables? X. Because remember, when we're looking at these, it's the biggest number that divides in, and it's the smallest exponent on a common variable. In other words, every one of the terms has to have that variable or I can't pull it out. So like if in this first one it just would have been 5x squared plus 10, I wouldn't have been able to take an x because they didn't have that in common. But I could in this case because I had the x. And then it just becomes the backwards distributive property. 5 times what gets me to 5? Well, 1. I didn't have to put the 1 there, but I can. And if I have 1x and I need to get to 2, I get 1 more. With the second part, 5 times what gets me to 10? 2. And I already have the x, so I'm good. And if I were to do the distributive property in this case, 5x times x is 5x squared. 5 times 2 is 10, and I have the x. And I'm good to go. Okay, so that's all I do up there. Now, is it always going to go in real nice for me? Not necessarily. If we jumped over to number 11, is anything going to 6 and 20? Because I know 6 itself doesn't go into 20. Even if it's something that's small. 2, nicely done. Okay, and we've got the x again that both of them have. So 2 times what gets me to 6? 3. Okay, and I've already got an x here, but I need 2, so I need 1 more. 2 to get to negative 20, negative 10, okay. And I already have the x. So I'm done on that one. Simple as that. But again, that's when we're just being asked to factor. Nothing about solving, no equal signs, no anything like that. Now, if it says solve, you'll see an equals sign. And in this case, it's already factored. So if it's already factored, I'm just going to take each piece, even the part that's not in parentheses. And I'm just going to set them equal to 0 and solve the mini equations. So it shouldn't take you real long. How would I solve the second equation, though? Minus 7, good. And that's all there is to it. So if it's already factored, don't do something crazy. Don't like distribute or do something else like that. Just kind of work it through and go that route. And then our last part on this side is basically what we were doing up above, except now we're going to take it one step further and actually solve it. So like if we're doing a problem like 17, let's say, I've still got to go through and say, okay, what do these two terms have in common? Well, they both can be divisible by 2. They both have an x, so I can take an x out, because again, I take the smallest exponent with my variables. And once I do that, I've already got the 2, but I've only got 1x, and I need to get to squared. So I'll use x. How to get from 2 to negative 18? Take a shot. 2 times what to 18? 9. Thank you. And then again, once it's factored, you just take each piece that has an x, and then just solve the equations. So it's just making sure I take things far enough to the step. These all build on each other. It's like these do the two separate things to get me to the point that I can do this last part. And that's all we're going to be doing on that. So let's see here. Flip over. We get back into our factoring stuff here one more time. Again, when I see 4 terms, and I'm going to jump to number 20. Actually, I'm going to go to 21. If I pair those off, it's basically what we've been doing already, except we're going to just keep working along. No, sit down. So, in this case, they're both divisible by 5. What do I do for my variable this time? Do I just take x like we've been doing? Or can I get more this time? Right, because I can always take the smallest one. In this case, x squared's the smallest one. So I can take the whole squared. Okay, I've already got the 5. I got 2 x's, I need 3. So I need one more. I need to get from 5 to 20, which is 4, but I've already got all the x's, so that's good. And I remember, if I did this right, when I factor on the next one, I should get x plus 4 again. What can I take out of both of these guys? 3's. And I'll even take that one step further. Because here, if I took a 3, I start to look at this and I say, wait a second. To get to there, I'd have to do negative x in here. Well, that's not going to be the same. But what if I take negative 3 out of there? Well, I've already got the negative 3, so I can take an x. Negative 3 to get to negative 12 would have to be a positive 4, because otherwise negative times negative would be positive. That wouldn't work. And they're the same. Hallelujah. So to get the answer now, I copy down the set of parentheses we have in common, and then those parts that were on the outside make up my other set of parentheses, and I'm done. But I got to get the factoring done right in the first part, but it's nice to have that little backup plan to be able to work with. And then the last part here is just kind of some review stuff again. Okay? When I'm adding or subtracting, I just combine like terms, but that subtract means I got to distribute the negative. So I'm going to leave this first part alone. And I'm going to switch the signs on all these, because that's what subtracting is. It means take the opposite. So negative becomes positive. Now, I'm not quite done. I do still at this point have to find the things that are alike and combine. Now, I'm not going to mess with the exponents anymore, though. Got a buck, I spend 8. I'm 7 in the hole, but they're still x squareds. Negative 2x and positive 2x, well, they're opposites of each other. They just cancel, so they just go away. That's good. And then 7 plus 5 is 12, and I'm done. And then the last one we're going to do on this one, and then I'm just going to go a little bit into the review one, is 25. Because again, we've talked about this too. If you have two binomials, two things that have two terms that are in parentheses, you can do the old FOIL way with all the lines and stuff. But we've found before that organizing ourselves a little bit with these is another option that I have. So when I multiply, I add the exponents, and I'm multiplying to fill the box. X times 9 is 9x. Negative 7 times 2 is negative 14. And again, we're still multiplying. 9 times negative 7 is negative 63. And the only thing I've got left to do now, I don't see any other x squareds. I see those are the same though. No more messing with the variable though. Negative 14 plus 9 is negative 5. And I'm set at the end. So I see how all those things work. And I put together what I can. Nothing else is the same anymore. There's no like terms left to put together, and I'm done. So that's basically what you're going to be looking at tomorrow. And I wish I could separate these things to be able to get those going. But unfortunately, and we're going to talk a little bit about some of the stuff we've been doing throughout the semester. Now again, I'll do one of each of these to kind of get us going. So for instance here, find the distance between each pair, draw a triangle and use the Pythagorean theorem if you'd like. So I'm actually going to start down at number 3, and I'm going to come back up here to number 1 in just a second. So if I've got a picture already, I'm trying to figure out how long this line is. So if I have a picture already, if it's already drawn in, one thing I can do is make a triangle out of it, and then say, okay, well, how long is each side? Huh? 1, 2, 3, 4, 5, 6, 7. Okay, this side's 8. And this side is 1, 2, 3. Okay. And I can use something like the Pythagorean theorem to help me figure out what the length of my hypotenuse, or my longer side, is. And I do that by just taking the squares of the two sides I know and figuring it out to the other side. Now, will these come out nice sometimes? Sure. Will they come out as decimally sometimes? Yes. So what we're going to do and whatever answer I get when I do their squares, I'm going to take the square root of it. And if I get a decimal, that's okay. We'll just round to the nearest tenth here, and we'll be good. Well, what if I don't have a picture? What do I do then? Well, I can do one of two things. I could either sketch a picture like this, make myself a little graph, plot the points, and then go. Or I can use the formula that goes along with this. Like, okay, a formula. How's that go again? So my formula on this one, oops, that's D for distance. Sorry about that. Is I would subtract my x's and square them. I'd subtract my y's and square them. And then I'd add those two answers up. So, what I could do here, and I always like to put all my symbols in first so I don't mess them up later. So I say, okay, here's my x's. So I have -3, -5. And then for my y's, I've got 7 and 1. And similar to what we talked about earlier with the quadratic formula, I wouldn't do the square root part right away. But if you wanted to put in here everything else that's underneath, that's okay. So this would be the square root of 40, and the see, square root of 40 is about 6.3. And that's all I'm doing. But again, I could sketch myself a little picture like I did down here if remembering formulas isn't my strength. Find a way that works for you and work it that way. When we get to equation world down here, just like always, if there's parentheses, I'm going to deal with that first. Again, we're multiplying when we distribute. Can't ignore that negative there. If I ignore the negative, I'm not going to get the right answer. I'll just let you know in advance. So when we multiply and distribute, once the parentheses are gone, now it becomes what's alike that I can put together. Well, these n's are, but again, just because it's combined doesn't mean we add every time. If I owe somebody 21 bucks and I borrow 2 more, now I owe them 23. But once I get those n's together, my new job becomes to isolate that. So let's see here. So I've isolated my n term. And again, I'm not subtracting 23 here. I'm multiplying negative 23 times that. So we're going to divide by negative 23. And I believe the answer is going to be 7. But it's all about parentheses, combine like terms, opposites, to kind of work your way through those. So let's see here. Exponents. I'm going to leave number 14 alone for right now. All right, only should have positive exponents. Multiply exponents when power to power. So here, that 2, whatever exponent's outside's got to get distributed all the way through here. So I'd have 2 squared, 1 times 2 for my m, and 3 times 2 for my n. Now, would I have to do this on a test? No, but it's nice to see. So if you look at it later, you're like, now, how'd I get that answer? 2 squared, 2 times 2 is 4. 1 times 2 gives me an m squared. 3 times 2 gives me an n to the 6th, and I'm good. And the only other thing that can kind of get thrown in as a twist as we're doing these is if I have something like I do on 17, I'm still going to distribute it. I'm still going to multiply them. Okay, power to power is always multiply. 3 times 3 is 9. 4 times 3 is 12. 2 times 3 is 6. But this time I can do a little something. Now, am I still going to be multiplying the exponents? No. When we get down to multiplying, we add the exponents. So 9 and 6 is 15. And then I don't have any other y's to combine anything with. And that's all I would do. It'd be the same thing I'd be doing on 18. I'd deal with the parentheses first and distribute, and then you just multiply the numbers, but you add your exponents. And we kind of just keep playing with this stuff a little bit as we go. Let's see what else we got here. Definitely want to do a couple of them back here. All right, simplify. Your answer should only contain positive exponents. Subtract exponents when dividing. Big minus small, the answer goes with the bigger exponent. Okay. Well, I see only one number, so I'm going to leave the 3 there. Then I get to m. And I say, okay, here's my m's. Big minus small, 4 minus 1 is 3, but the bigger exponent's down below. So that's where my answer goes for my m part. Then I do it for the n's. 3 minus 1 is 2. The bigger exponent's on top, so that's where I leave it, and I'm done. Now, will there be some times sometimes I got to do more than just that? Oh, yeah. Like 22, prime example. There's multiplying to be done first, so we have to do that. So up top, okay, I see a 2. There's my a's multiplying. I add the exponents. 3 and 3 is 6. I'll just copy what's down below. And then I do what I did up here. Now, if I try to do 2 divided by 3 and I get a decimal, just leave it. A's, 6 minus 4 is 2. Bigger exponents up top. B's, 3 minus 1 is 2. Bigger exponents down below. That's how I figure that out where they go. But again, just a little bit of assistance as we go along, trying to make this a little bit easier for you. And I think, oh, it's the end. Well, all right. So my main focus, if I was to put some right now, even though this is important, I mean the final, we've got a couple of days though, I'd go back and just finish up some of these on the review. That's going to best prepare you for our little unit test tomorrow. And then we'll be spending the rest of our time working through some reviews, talking about questions, and making sure we get things straightened up for you.